Hello there. This is the second class of the chapter Mathematical Reasoning, and as previously, Avishek Paul sir is collaborating on this edition as well, and he is going to share some of the theory part with us. Now, before we go into the theory part, let us take up thing which we have done previously or which he explained to us previously, but we didn't solve any problem. So we will be taking up few examples from the stuffs which we have already done previously, and then we will slowly move into the topics which we have today. So the things which we are going to discuss in this class is logical connectives. Now remember, logical connectives is one of the part which sir has already discussed in the previous class. So we are going to solve few problems. Then we are going to talk about quantifiers, then the idea of implications, and finally converse, inverse and contrapositive of an implication. So now, logical connectives, as if you remember, or you can just go back to the previous class and check that logical connective means if we have two simple propositions, and when we connect the two simple propositions and make it a compound proposition, then the connecting words or the connectors which are used, they are called the logical connectives. So we basically have two logical connectives which are and or. So let us take few example, the kind of example which we require to solve in the subject of mathematics. That is, you will be given a compound statement and you have to write the components of the statement, and also you have to state if the compound statement is true or false. So the first example, a line is straight and extends indefinitely in both directions. Fine, this is our compound statement. So from here I have to write the component statements or component propositions, and we have to write if it is true or false. Now it is pretty easy to see the component statements. The first one is obviously a line is straight, and the second one will be a line extends indefinitely in both directions. Fine. And what is the logical connective here? The logical connective is and, obviously, and is the connective which is connecting these two simple propositions or the component statements. And then, is it true? Now obviously remember that if we have the connective as and, then for any compound statement connected by the connective and to be true, then both the component has to be true. If any one of the component is false, then the whole compound statement becomes false. So here a line is straight, yes, it is true. A line extends indefinitely in both direction, yes, that is also true. So I can see that both the component statements are true, so therefore the whole thing is true, right? Next, let us move to the second example. Sun and moon both are bigger than earth. Now easy to see here, what are the component statements? The first component statement is sun is bigger than earth, and the second component statement is moon is bigger than earth, and obviously the connective used here is and. Now to check if it is true or false, so let us see. Now sun is bigger than earth, this is definitely true, but earth I mean moon is bigger than earth, that is definitely not true, it is false. So one of the component statement is becoming false, so therefore the whole component or the whole compound statement is becoming false. Fine. Let us take the third example. In the third example, we have 125 is a multiple of 7 or 8. Okay, so let us take the third one separately. The third one is 125 is a multiple of 7 or 8. Now, what will be the component statements? The component statement is 125 is a multiple of 7 and the other one is 125 is a multiple of 8. And the connective used here is OR. Now, if you remember, if the connective is OR, then if any one of the component being true, then the whole compound statement becomes true. But here in this case, we can see none of the component statement is true. 125 is definitely not a multiple of 7, so it is false. Again, 125 is also not a multiple of 8, so it is false once again. Both becoming false, therefore the whole compound statement is false. Fine. Let us take the fourth example. Fourth example is a rectangle is a quadrilateral or five-sided polygon. Again, the component statements are a rectangle is a quadrilateral and a rectangle is a five-sided polygon. Then the logical connective here also is OR. Now, to check the truth value, a rectangle is a quadrilateral. Yes, obviously it is a quadrilateral, so it is true. A rectangle is a five-sided polygon. Definitely not, it is false. But as it is connected by OR, one of the component statement becoming true, that means the whole compound statement is true. Fine. Now, let us move to the next part. In the next part, we have identify the type of OR used in the following statements and give reason for your answer. Now, identifying the type of OR. Now, OR can be of two types. One is an inclusive OR and the other is an exclusive OR. Now, what does inclusive and exclusive means? Inclusive means if both becoming true at the same point of time is possible, then we call that case to be inclusive. And if any one of the two is true, then the other is not true or other is false, then we say that it is the case of exclusive. Fine. So let us take an example and understand. So the first example, a lady gives birth to a baby boy or a baby girl. Now you have to identify that this or the baby boy or a baby girl. So here this is the or which we are talking about. Is this or inclusive or exclusive? Now pretty easy to see here that it is exclusive. Definitely it can't be inclusive. Why? The reason being that whenever anybody is giving birth, it doesn't matter if you are giving birth to a twin, you are giving birth to a triplet, you are giving birth to n number of babies, doesn't matter, but at a single point of time there will be only one baby coming out, and that baby has to be a boy or a girl. Now to be politically correct, we also have a third gender, but definitely just for the sake of the problem and sake of duality, considering that only a boy or a girl can be a thing, the third gender is not a thing, then obviously given all these assumptions made, then this is definitely exclusive, right? Then, so let me write here E. So E will denote that it is exclusive. Fine. Let us move to the next one. To enter a country, you need a passport or a citizenship card. So here again, this is the or we are talking about. To enter a country, you need a passport or a citizenship card. Now also it is pretty easy to see that this is going to be exclusive. Why exclusive? Because you see, when you are entering a country, now if you are coming from a different country, obviously you need a passport to enter into that country. And then if you are not having a passport, or if you want to enter another country separately, then what you need to have, either you be a citizen of that country if you don't have a passport, or you apply for citizenship and you get the citizenship and then you enter. So in any of the two cases, obviously having a passport and having a citizenship, they are not simultaneously possible. So it is definitely not possible. So therefore it is an exclusive case. So therefore again this is E. Then the last one, Richa is truthful or punctual. Now this can be a little bit debatable, and this can be controversial as well, because a person being truthful need not be punctual, and obviously a person being punctual need not be truthful. But here, for the sake of the fact that one person who is truthful means having this one good quality can also have the other good quality as well, because a person being truthful can definitely be punctual, because both the condition can happen to one person. So always remember that here we are going to consider the all possible cases that can happen. Now in the first two cases we can see that both happening together is not possible, so therefore that is the reason why it is exclusive. But in the third case we can see both happening together is possible, so a person can be truthful and punctual at the same point of time. Means obviously it is definitely, you need not be so, but definitely the case that a person can be so. So therefore this particular or which we are having in the third case is an inclusive or. Inclusive in the sense both can happen at the same point of time, means there are chances of both happening at the same point of time. Fine. So this is how you identify a or to be inclusive or exclusive. Fine. Let us move to the next one. Now the next topic is quantifiers. Now what are quantifiers? So quantifiers are basically, by the word you can understand, quantifiers. So from the word quantity we get the word quantifier. So from the quantifier is basically giving us the idea of the number of things we are talking about. Number of things we are talking about means in a statement we can definitely make use of words which describe the number or amount of certain quantity in the statement. So therefore the words which is describing an indefinite set of number. Indefinite set of number means if I say there are two people, so this two is a quantifier. It is quantifying a number, but it is a definite number. So therefore this two can't be called a quantifier according to mathematical reasoning or propositional logic. But whenever we have word which is describing an indefinite set of number, indefinite set of number means not an exact number, but it is giving us a sense of number, then that is called a quantifier. For example, the words like for every, for all, there exists. So these are all giving us a sense of number, but it is not giving us the sense of exact number, but it is giving us a sense of an indefinite set of numbers. So whenever I am saying for every, it means that every single item, whatever we are talking about. And then whenever saying for all means whatever we are talking about is happening to everybody or everything, for the matter of fact. There exists. Whenever I am saying there exists, I am talking about at least one thing. It can be one or it can be more than one as well. So we are not getting the exact picture of how many, but definitely we are getting a sense of how much. So that is why it is called a quantifier. Let us move to example. Example, identify the quantifier in the following statement and write the negation of the statements. First one, there exists a number which is equal to its square. So obviously, what is the quantifier here? The quantifier here is there exists, as we just discussed. And then if I want to negate the statement means we are trying to write the opposite of it. So read the statement once again. It says there exists a number which is equal to its square. So you can write there does not exist a number which is equal to its square. That is one way of writing the negation. Or you can write there exists a number which is not equal to its square. So obviously you can write that as well. Right? Fine. Done. Next, for every real number x, x is less than x plus 1. So if I try to write, obviously here the quantifier is for every, and if I try to write the negation of it, so for every real number x, x is not less than x plus 1. That is one way of writing the negation. Also, there is a fancy way of writing it. Fancy way of writing is something like this. You can say there exists at least a real number x such that x is greater than x plus 1. So here also it gives us the same sense of idea, that is whatever the statement is given, it is just giving us the negative of it. But it is another fancy way of writing the negation. Right? Now let us come to implication. Now about implication, our Paul sir has described a little bit of it in the previous class, what he described as a conditional statement or conditional and biconditional operation or biconditional operators. He described it. So let me just give you a brief description of the same thing but in a little bit different way. If P and Q are two propositions, and if occurrence of P implies occurrence of Q, then we say that P implies Q, or if P then Q, which is pretty intrinsic and obvious to understand. And then we denote it by this symbol, P implies Q. Now implication symbol can be different in different book. So this is how we denote an implication. Now P is called the sufficient part, means it is sufficient for Q to happen if P happens, and then Q is called the necessary part. Necessary part in the sense P happens, then only Q happens. So therefore Q is called the necessary part. Also P is called the antecedent, it's another way of saying it, and Q is called the consequent. Fine. Now antecedent and consequent, these two words are not much used in mathematics, but it is used in computer. In mathematics we much more use the word necessary and sufficient. So sufficient means the first part, necessary means the second part. So that's how you remember it. Then let us take some example. So the first example is, knowing the question paper in advance is the necessary condition for getting an A grade. So knowing the question paper in advance is one statement, and getting an A grade is the second statement. It is told that knowing the question paper is the necessary part. So knowing the question paper being the necessary part, if I am trying to write it in the form of if P then Q in this way, then what happens? This becomes the second part, or that this becomes the consequent, and this becomes the antecedent. So how we write it? We write something like this. If you get an A grade, then you have, please forgive my grammar, you have known the question paper in advance. This should be known. Please have some mercy on my grammar. Fine. Then example number 2, knowing the question paper in advance is the sufficient condition for getting an A grade. So in that case, as it is given that this is the sufficient condition, so that means this becomes the consequent and this becomes the antecedent. So therefore, if you write in the form if P then Q, then it will become, if you know the question paper in advance, then you will get an A grade, which is more obvious, right? Next, number 3, you can access the website only if you pay the subscription fee. Now, only if you pay the subscription fee, so that means what? This is very much important. This is necessary. If you don't pay the subscription fee, you are not going to be able to access the website. So this is the necessary part. So now, if you are given such question, you have to understand which is the necessary part and which is the sufficient part. Now, it is just a little bit act of common sense. By reading the question itself, you can understand which is going to be the necessary part and which is going to be the sufficient part. So it is said that you can access the website only if you pay the subscription fee. So paying the subscription fee is important. It is necessary. So therefore, this is the necessary part. And as it is the necessary part, so you know that it is the antecedent and you can access the website is the, I'm sorry, I just misinterpreted. If you pay the subscription fee, as it is the necessary part, it is the consequent, and you can access the website as it is the sufficient part, it is the antecedent. So therefore, when you are writing it, it is going to be something like this. If you can access the website, then you have paid a subscription fee, right? Next, last example. You get a job implies that your credentials are good. So it is already given in the form. You see, P implies Q. That is the form. P is the sufficient, Q is the necessary part. So therefore, you get a job implies that your credentials are good, means if you get a job, then your credentials are good, obviously. Now we will be moving on to the next part, where Abhishek Paul sir is going to give us the idea of contrapositive, converse and inverse of an implication.
Converse, inverse, contrapositive. So speaking about converse, if I take two examples of propositions, like P is denoting it is raining and Q is denoting sky is not clear, then this P implies Q, that is this conditional part. If you say that if it is raining, then sky is not clear. Okay, so the converse of this implication part will be termed as Q implies Q. Okay, so the statement will be, if sky is not clear, then it is raining. Okay, so basically you are reversing the sides of the antecedent or consequent. Okay, so next part, inverse. So with that same example, if we take that P implies Q is giving us if it is raining, then the sky is not clear, then its inverse will be P dash implies Q dash. So you are going to make the negation of both the antecedent and the consequent. So it will finally result in a statement like, if it is not raining, then sky is clear. Now moving to the next part, with the same example, contrapositive will be defined as Q dash implies P dash. Okay, that means the side of this consequent and antecedent will be changed with the negation version of it. Okay, so the statement, if it says that P implies Q, represented as if it is raining then sky is not clear, then it will be termed as if sky is clear then it is not raining. So this is the part of converse, inverse and contrapositive.
Now coming back to the example, sir has already explained nicely taking one example. Now let us take another few set of examples and understand this idea of converse, inverse and contrapositive once again. So let me take the first example. The first example is, if a number n is even, then n square is even. So now let us write the converse part. Now converse part, as sir explained, if P implies Q is the statement, then converse is just the reverse of it. So Q implies P. So if n square is even, then the number n is even. Inverse means not P implies not Q. So if a number n is not even, then n square is not even. And contrapositive, not Q implies not P. So if n squared is not even, then the number n is not even. Second example, if you do not work hard, then you will fail in the test. It's converse. If you fail in the test, then you did not work hard. Just reverse it. Then inverse. If you do work hard, then you will not fail the test. So just whatever is the statement, both the parts, you just negate the parts and you write as it is. Contrapositive is just opposite of inverse. You negate both the parts, but you reverse it. So if you do not fail in the test, then you did hard work. Last and the final example, if my grandmother had wheels, she would be a bus. Now this is a classic British way of explaining and exaggeration. Now if somebody is exaggerating, so then you can say this, this is more like an idiom. If my grandmother had wheels, she would be a bus, means this is just an example of how you exaggerate or over the top exaggeration. So anyway, let us come back. Now let us write the converse part of it. So converse, if my grandmother was a bus, she would have wheels. Fair enough. Inverse, if my grandmother did not have wheels, she wouldn't be a bus. And finally the contrapositive, if my grandmother was not a bus, she wouldn't have wheels. So I hope this gives you a clear picture